Hey guys, this is Srini here, and you're watching basic Python tutorials on my channel Python for Microscopists on YouTube. And again, these videos are intended for beginner programmers who are students, researchers, and also anyone who's interested in learning how to do image processing using Python. Now, today, let me summarize exactly what we have learned until now, and especially the last couple of tutorials, because we have done lists, which are these are basically the foundation, I should say, for image processing, because images are nothing but two-dimensional or multi-dimensional lists. So let's quickly summarize what we learned until now. So again, this is an IDE. I'm using Spider IDE, which is part of Anaconda distribution. So to install this, just go to search for Anaconda Python and install it for whatever operating system you're using. Now on the left-hand side, this is where I can type a bunch of text and execute it, which where the results are. I can look at them on the right-hand side under IPython console. And in the IPython console, I can also type individual commands like a equals 3, and here I assigned an integer of 3 to a variable called a, and on the top I have Variable Explorer open, so I can see that okay, I have what variables do I have here. Now there are different types of data types. So if I do b equals 5 point, now, because I put this decimal here, it's going to automatically consider b as a floating point number. It can also be a string, so it can be, let's say, let me just type my name. Now c is a string in this case. So these are different data types, and then we realized we can do a lot of math with these numbers. Now, another data type is a list. So if I just do d equals 1, 2, 3, 4, 5, this is a list. And a list is defined by using square brackets. And then a list can be integers, it can be floating point, it can be text, and you can mix them. So I can actually, let's overwrite our d, and let me just do one, and then the next one can be my name, and the next one can be 5 point. So here you can see that d is still a list, but it has different types of data types inside this list. And another type of list is called a tuple. So again, a tuple is defined by parenthesis, and you can just do 1, 2, 3, 4, 5, let's say, and right away you see that this is a tuple. And tuples are immutable list, which means you cannot change them. You cannot remove certain element from a tuple. From a list, you can delete a subset of those. You can add, you can modify the list, but a tuple you cannot modify. You can copy it. You can actually create a subset of it. So for example, if I want e equals d, and I just want element number 3 here, and my e is nothing but number 4. I mean, I typed 3 here, but I got 4 here. That's because this number here is the index. Where is that number stored? So if I have, just to make things a bit simple, let me just do, I don't know, AAA. Well, it would be nice. Let's say I am Srini. Okay, so I defined this tuple, and here I is at the position 0, am is at the position 1, and Srini is at the position 2. So if I say d2, then at position 2 I have Srini. It's returning that value, and I can assign that to something else. That's exactly what we did before. E equals d, the second element there, and my e now is Srini. Okay, so you can take a tuple, you can copy the elements from that, but you cannot modify a tuple. And then we realized that, okay, let's go back to our list. What do we have for our list there? Well, let's redefine this. So I'm going to redefine our list as 2, 4, 6, 8. Now I want to do some math to this list. So I want to multiply this by 2. So what I'm expecting is to get 4, 8, 12, and 16. A list of another list that actually is 2 times a. So if I just do that, a times 2, instead of getting 4, 8 and 12 and 16, I actually got 2, 4, 6, 8 and 2, 4, 6, 8 another time. So this is not really useful if you want to do image processing. If you want to increase the brightness by 2 times, if you want to multiply every element by 2 times, this obviously is not useful at all. One way to achieve this is you can actually say b equals, let's say, let's start another array here. B equals I multiplied by 2. What is I? I is every element in this list. I multiplied by 2 for I in A. Yeah. So if you execute this, your B would be 4, 8, 12, and 16. This is exactly what we expected to get right from the beginning. So this is a very quick crash course on exactly what we learned until now, but then we also realized that, okay, so writing all of these, like I multiplied by 2, using for loops and everything to do simple math for lists is a bit tedious, too much code. How can we actually do it in a better way? And that's when we realized that NumPy is a great library that that can really help us. And if you use Spider, you probably already have NumPy installed. So just do import NumPy NumPy, and then it imports that particular library, and all the functions within that library are accessible to you. Now you can actually do various functions, which we'll see in a second. If you don't have NumPy, then do pip install NumPy, and when you hit return, let's go ahead and do that. When you hit return, this may take a couple of minutes, it actually goes through and then installs NumPy or whatever the latest version is. You can specify which version of NumPy you need. In this case, it says requirement already satisfied because I have NumPy already installed. But now let's actually, why do we import NumPy? So let's do this one more time. Import NumPy, because now it's a bit difficult to type NumPy dot something every time. So we can actually import NumPy as an abbreviation. So we can say import NumPy as NP, for example. What that means is now I don't have to type NumPy. I just need to type NP. And how do we access individual functions within a library? You do np dot, and then it shows up. In fact, if you type that in the text editor right here, when you do import NumPy as NP, and when you say np dot, then it should actually open up all the available functions within that library, and array is one of these. Instead of searching there, I'll just go ahead and type np dot array. Okay, so this is how you can actually import functions within within a library. Now, what do I want to do? np.array. In fact, let's go ahead and define an array first. Yeah, let's say a equals 2, 4, 6, 8, and this is our a, which is nothing but a list. Okay, I want to convert this list into a NumPy array, and the way you do that is np.array. I could have just said np.array 2468, but let's just assign this to a different variable, b equal to np.array and a. So now if you just do and this converts our list into an array. Again, now you can actually do type. I'm actually thinking about what is the best way. Since we already talked about these in detail in the previous videos, let me just keep this at high level. So I'm back here onto the console because the result is instantaneous. So import NumPy as NP. Now let's just do np.array. And I'm just going to define my array here. I could have just assigned it to, A and then all of that. Well, let's actually do directly assign this to A. A equals np dot. Apparently, I cannot do that. A built-in function or method not accessible. So let's do this. 2, 4, 6, 8, and let's see. B equals np dot I'm not going to troubleshoot that or think about it right now. I know I made probably a very silly mistake, but I just want to proceed with this right now. So when I do B, you can see B is, in this case, int 32. You see the size, it says instead of just 4, it says 4 comma and within this parenthesis. That means the size of a NumPy array is a tuple. Okay. So in this case, we have our B as 2468. And now if I do B multiplied by 2, you can see that it's actually 2 times this. B squared, B to the power of 2, B squared. Now it's actually doing the square of these numbers. So NumPy makes math very easy. And this is just one dimension. This works in any dimensions. You can multiply. I can actually, let's see, where is our, let's do our B. B is this NumPy array right now, right? So when I type B, it clearly tells me that this is a NumPy array. And if I actually, you can add multiple, NumPy arrays and so on. Now, also we ended the last tutorial by looking at an image as a NumPy array, because image is nothing but a whole bunch of numbers. And how did we look at this image? And we actually used, you can use multiple libraries to open an image. We used something called, I believe, SciPy. So from SciPy, under miscellaneous, MISC, under miscellaneous, you have functions to import im read and im save. So im read actually reads an image, and im save, as the name suggests, it saves an image. And then let's go ahead and save this. What's our present working directory? I'm working here, which is okay. So within images, I have a few images that I can open. So now I just need to assign image equals im read, and where is it? Under images, and I believe there is a JPEG, test underscore image.jpg. So image.jpg, and so that reads the image. Now let's go ahead and print this image. Print img. So all I'm doing is opening an image. I'm just printing it on the screen. So when I print that, you should see that this is a whole bunch of, this is the NumPy array right there. Yeah, the image is nothing but a whole bunch of numbers. And this is a color image. And this is a color image. In fact, if I open this image, let me go ahead and open so you can see exactly how it looks like. PFM, Python files. In fact, let me go ahead and bring this screen to the right-hand side. And under images, and test underscore, let's go ahead and delete this because this is from yesterday. And when I open test underscore image.jpg, you should see, well, it opened on my other screen. So let me go ahead and pull this here. So this is a biological sample microscope image, and it's a fluorescent image. So you can see the green channels, you can see like red markers here, you can see the blue ones, and blue ones appear to be nuclei. Now let's say I just want to look at only the blue channel. I want to suppress the other channels. So then what we did yesterday was, remember, you can do matrix multiplications and all of that. So let's actually define something called image tinted. I want to tint this image equals to, let's take this image, which is our color image, and multiply this by, and again, the image has 3 channels. The first one is red, second one green, third one blue. So let's multiply 0 to red, 0 to green, and 1 to blue. This is it. So now it should, now let's go ahead and say im save. Let's save it same under images, and let's call this tinted.jpg. And what is that image? TINT. So here I'm just saying save. What do we want to save? We want to save this image underscore tinted. That's what it is, image underscore tinted. And save it where and under what name. Save it in images as tinted.jpg. So if I run this, let's go ahead and run this and open, and here is the tinted.jpg, and we should just see only the blue channels right there, yeah, because we kind of suppressed the red and green. This is really the basic image processing right here, but in reality there are libraries like scikit-image that actually, where they already have all the functions. For example, they probably have, I'm not sure, they probably have something to extract a single channel from a multi-channel image like RGB image. So in reality, we are going through all these lessons or lectures and tutorials about reading lists and doing math and everything. But for bulk of image processing, unless you want to write your own, define your own filters, come up with new filters, and do all kinds of advanced, come up with advanced algorithms. If you really want to do like a basic image processing or even advanced image processing, where you extract filters from your features from your images and do machine learning, all of that, it's literally a couple of lines because someone already have written these functions for us. We just need to call them. We just need to use them. That's pretty much it. So these are lectures for you to give enough background in Python in general, but just doing basic image processing, you may find it very underwhelming because it's very easy. Okay, so let's continue with learning about lists in our next tutorial. So thank you very much.